What's up, spaceflight enthusiasts and scale modelers? Welcome to Model Kit Discussion. It's your host, Ray. In today's video, I'm going to be talking about my 1:200 scale replica of the Space Shuttle Challenger. This is the Hasegawa Hobby Kit's Space Shuttle kit, and I built this in March of 2023. It took me about a week to complete, and here it is. In this video, I'm going to talk about the building process, things that I had to deal with, any challenges and difficulties that I had. And after I discuss the building process, I'm going to talk about a little bit of history behind the Space Shuttle Challenger and why I chose to build this kit. That being said, this is going to be a pretty long video, so sit back, relax, and let's get this started. Before I begin my discussion, I'm going to give you a quick 360 of the model so you can get a good look around it. So I built the Space Shuttle Challenger in the configuration it was in for mission STS-51L. For those of you who are unaware, STS-51L was the 25th Space Shuttle mission out of the Space Shuttle program, the 10th launch of the Challenger, and the final launch of the Space Shuttle Challenger, and also the first disaster in the Space Shuttle program. More information on that will be later in the video. Construction of the orbiter was relatively simple and straightforward. This was my second time building a Hasegawa space shuttle. The first time I did a replica of the Space Shuttle Columbia, and I also did a video on that, so if you want to see that, the link will be down in the description, or if you want to scroll through my videos, it should be down there somewhere. So given this, I had an idea of what I was getting myself into, and I was better prepared to deal with the difficulties associated with building this kit. I also didn't have to make any extensive modifications to this kit because I was building an early era space shuttle, and that's what this kit is modeled after. It's not modeled after the later variants, or not variants, but later space shuttles which had different modifications and appearances to the earlier ones. So construction and some of the fine detailing was a little bit more straightforward this time around. However, that doesn't mean that this kit didn't have its problems or its challenges. This kit is actually a pretty nice one, especially since it's from the 1980s to my knowledge, or even the late 70s. It's still a pretty solid kit for today's standards, and the construction is relatively simple and straightforward. The difficulties that I started experiencing were mostly in the fine detailing. Up here, the cockpit windows were pretty hard to put on because it's a decal that goes over the window frames, and while it is nice that there's a decal for that, it's very hard to get to conform to the surface of the windows. And you can kind of see that the frames are indeed engraved. Well, they're not engraved, but there is raised detail to replicate the windows themselves. And getting the alignment on that was pretty difficult, especially with water under the decal. It's very hard to see raised lines through that water, and I'm very glad I was able to get the alignment there. Aside from that, everything else with the assembly of the crew cabin was pretty straightforward. The only other issue that I had was painting the fine detailing here with the thermal protection system on the RCS thrusters. You can see I didn't do the best job there, but I got the job done, so I can't complain too much. But yeah, aside from that, it went pretty straightforward. The crew cabin looks nice in my opinion. I think I did a decent job on it, so I'll just show you around there, and yeah, that's what it looks like. Moving on to the fuselage, I also had a different set of challenges up here involving the decals, specifically with the payload bay hinges. You can see the payload bay hinges have a certain pattern for each of the different shuttle variants. Like later in the lifetime of the space shuttle, they had a very different payload bay hinge thermal protection configuration than in the early days. And this is what it looked like in the early days. And I actually had to make my own custom decal, well, not custom decals, but I had to use spare decals that I had and cut them in such a way to make the correct rectangular shapes for each section of the payload bay hinges. The first 6 were thick rectangles, the next 4 were very small lines almost, and the last 3 didn't have any hinges on the fuselage part, or not hinges, but it didn't have any black thermal protection system on the fuselage part, so I didn't have to make decals for that. It was still pretty challenging though, and on the payload bay door itself, I didn't put any decals. These markings are hand painted in order to facilitate the assembly process, because the hinges on the payload bay doors are actually hinges. It's not just a flat surface that would make decal application easy, so that's why I chose to hand paint it. And I think everything came out well. This is obviously the left side. The right side came out pretty good as well, and the best part is that the payload bay doors still open, so I can't complain there. On the inside, I fitted the included module here. I'm not even sure what this is called. I'm pretty sure it's supposed to be a replica of the Space Lab. I'm not 100% sure. But still, I decided to paint it silver because why not? And I put the good old NASA worm logo on there because it looks cool. And I really don't like having this thing displayed with the payload bay doors open. I prefer to have it closed, but I still have it in there because why not? And on the off chance that I do want to display the model with the doors open, I want something to be in there. The payload bay doors on this kit, normally they fit pretty well. However, on this specific example, I had to sand them down in order to get them to fit correctly. Before I sanded them, they were too large for each other and they wouldn't conform completely with the rest of the fuselage. So it did require a bit of sanding. You can see it required a lot of sanding, especially here up front because I left a little bit bigger of a gap than I should have. But it's still within my acceptable margin, so I think I did okay with that. During the 360, you might have seen that the American flag on the right side of the spacecraft is kind of damaged. And this is actually kind of unintentional, if you will. It is kind of unintentional, but I had to do this because the decals that I used were from two different kits. The kit that I bought didn't have decals for the Challenger, but the kit that I bought previously, which was the 747 shuttle carrier aircraft, had the decals for Challenger, but it didn't have the right flag configuration. The American flag on the right side of the spacecraft is reversed from the left side because that's how the American flag is to be displayed on vehicles. But the decals on the kit didn't replicate this successfully, so I had to break up this American flag and put it in the correct orientation for the most accuracy. There wasn't any 1 to 200 scale space shuttle decals that I could get either, so this was my only option, and it turned out okay. It's not the best, but it's not the worst either. Moving towards the aft end of the orbiter, back here everything else was pretty straightforward. I didn't really have any issues with fine detailing. However, you can kind of tell that the black thermal protection here is not a decal. This is actually just painted on, and this was a challenge and a half. Okay, I keep saying challenge, and this is a shuttle Challenger. I'm sorry, I just noticed that. But this was extremely difficult because I had to do multiple paint coats in order to make sure I got the places that I needed to cover. And to do these thin lines here, I cut, you guessed it, more decals, and I think I did an okay job there. And you can see two even smaller lines right here. These are also decals, and they're not the best because, well, I'm not the best at cutting decals, but I still think I did a decent job there. So what I was going for was the most accurate replication possible with the most practical means that I had. And hand painting this was out of the question, so my next best option was decals. Last bit of the discussion of the assembly process. Everything else in the engine section was good. The engines are designed to be gimbaled, however I glued them in place, and I kind of glued the center engine a little bit too high and it looks kind of funky now, but I think it's still within acceptable margins, so there's that. And here's the vertical stabilizer. Like I said earlier, I didn't have to make any modifications to this one because it didn't have the silts pod that Columbia had, and it didn't have the drag chute at this stage in its life, or Challenger never had the drag chute, so I never really had to make the drag chute modification here. Since Challenger didn't really have as extensive of a career as the other orbiters, I didn't choose to do any weathering really. The only technical weathering that I did was here on the wings. I made a little bit of a darker shade of white here, very light gray, by using very diluted water-based black paint in order to fill the gaps and make a little bit of a difference in the whites here, because this section was thermal protection tiles and this section was just bare metal from what I've been made aware. Or it might have been blankets, I'm not 100% sure, but it was not the tiles here. And since there was tiles here, it had a little bit of a darker appearance on the orbiter, so I wanted to kind of replicate that. And I followed it all the way up to where the metal or blankets ends, and it just transfers to completely tiles. I didn't do this on the fuselage though, because the Challenger also had tiles on the fuselage and around the crew cabin, and I chose not to do those because it just would have been too much work, and I don't think it would have looked the best either. So for this segment of the video, I'd like to talk about why I chose to build this spacecraft. The Space Shuttle Challenger was the second space shuttle in NASA's space shuttle fleet. Therefore, it was more of a production vehicle rather than a test vehicle. That role was reserved for Space Shuttle Columbia. It made its maiden voyage on STS-6, and even though Challenger had a relatively short career compared to the other orbiters, it still had a fair share of history that it made. It carried the astronauts that first made tests for the maneuverable spacesuit, which allowed astronauts to freely float away from their spacecraft without being tethered to it. And I mean, come on, that just sounds really cool. We've all wanted to float in space alone since we were kids. Anywho, it also carried the first American female astronaut, Sally Ride. And on its 10th mission STS-51L, it was going to make history again. However, it made history in a way that nobody would have expected nor would have wanted. When most people think about the space shuttle, the first thing that comes to mind is the iconic space plane from the 80s blasting off into the heavens. However, for many others, a very different image comes to mind. Mission STS-51L was scheduled to deploy satellite, observe Halley's Comet, and most importantly, host the first civilian to fly in space. After a series of delays, STS-51L started with the launch of the Space Shuttle Challenger on January 28, 1986.
T-minus 10, 9, 8, 7, 6. We have main engine start. 4, 3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
On board were 7 astronauts: Commander Francis Scobie, Pilot Michael Smith, Mission Specialist Ellison Onizuka, Mission Specialist Judith Resnick, Mission Specialist Ronald McNair, Payload Specialist Gregory Jarvis, and Payload Specialist and schoolteacher Krista McAuliffe. STS-51L was the first mission to fly a civilian into space. A teacher was chosen in order to promote spaceflight to school children and reignite public interest in the space program. NASA and its contractors were under great pressure to launch as soon as possible. This led to the dismissal of multiple safety concerns brought up by engineers. One of these was the concern of the reliability of the O-ring joint seals of the solid rocket boosters given the unusually cold ambient temperature. Mission managers overruled the engineers' recommendation not to launch. 73 seconds after liftoff, history changed forever.
Engines throttling up, 3 engines now at 104%.
Challenger, go at throttle up.
Challenger, go at throttle up.
An O-ring seal on the right solid rocket booster failed and allowed hot gas to escape and burn the external fuel tank. This resulted in a structural failure of the external tank, changing the orientation of the shuttle stack. At a speed of Mach 1.92, the orbiter was exposed to aerodynamic forces which overcame its structural capabilities, resulting in the disintegration of Challenger. The solid rocket boosters continued in flight for another 37 seconds before being destroyed by the range safety officer. Film analysis and investigation of the debris indicates the crew cabin remained intact after Challenger disintegrated. It was established that the crew survived the disintegration, and some of the crew members were conscious, if not all 7. The crew cabin reached a maximum altitude of 65,000 feet, then fell for over 2 minutes before impacting the ocean at a speed of more than 200 miles per hour, a speed at which is unsurvivable. On the ground, thousands watched in horror as the disaster unfolded, including school children and the families of the astronauts. The Challenger disaster resulted in the grounding of the Space Shuttle program for 2 years, during which the solid rocket boosters were redesigned to prevent another disaster like the one of Challenger from occurring again. The shuttle would fly again on mission STS-26 in 1988. In 1992, the Space Shuttle Endeavour made its first flight as the replacement for the Space Shuttle Challenger. Endeavour would go on to survive till the end of the shuttle program, making its final flight on mission STS-134 in 2011. The shuttle program had 88 more successful missions after the Challenger disaster. It wouldn't have another problem until 2003, 17 years after Challenger, with mission STS-107 and the disintegration of the Space Shuttle Columbia on re-entry. Both disasters serve as ominous reminders of the importance of the saying, safety first, especially when involving inherently dangerous activities such as spaceflight. Well, that's all I've got for you guys today. Thank you so much for watching and listening to my talk about my space shuttles. This is why I built them, because they have a lot of history behind them, and unfortunately they do have tragic endings, which we have mostly learned from, and we are still learning from to this day. That's all I've got for you guys today. Thanks so much for watching. Like, comment, and subscribe. Take care of yourselves. Stay tuned for more space flight and model airplane content. And I'll see you later.